Hello everyone, welcome back to this mini lecture. If you were able to follow the previous lessons, congratulations on having your very own homemade digital clock. In this lesson, we will enhance the functionalities of this digital clock. Let's begin from the following aspects. In many cases, the initial values of a digital clock are not suitable for the intended use and require users to reset them. However, not everyone knows how to change these initial values through low-level programming commands, which necessitates adjustments via external hardware settings. Today, we will build upon the basic display of time on the digital clock by adding button design features to adjust the time on the clock. In this lesson, we will learn to adjust the hour and minute values of the digital clock by using the function of external interrupt buttons. By utilizing basic logic gates, we determine the state of the button being pressed. Hardware-wise, we need two buttons, each controlling the values of hours and minutes respectively. Assume that pressing once will increment the corresponding value by 1. We connect a button K1 at P1.7 to adjust the current hour value, and another button K2 at P1.5 for adjusting the minute value. These two buttons are connected to the external interrupt 0 port P3.2 of the microcontroller via an AND gate, so that when either button is pressed, the microcontroller can detect it and immediately respond to the interrupt, executing the function associated with the button press. Let's first learn about the basic logic gate circuits. Logic gate circuits are electronic circuits that perform various basic logical operations. In Produce simulation, the search keyword for the AND gate is AND, which is also the logic gate used in this example. There are three basic logic gates: AND gate, or gate, and NOT gate. Depending on the input states, the output states will vary accordingly, and this can be checked against the truth table. The input characteristic of the AND gate is that if there is a low-level input at any port, then the output will definitely be low-level. This is also the logic we use in this example to determine whether a button has been pressed. The art of program design primarily manifests in algorithm design and structural design. If all data definitions, flow control statements, and input-output operations are coded within the main function, it complicates program modification and debugging. The advantage of modular programming is that each module's program can implement corresponding functions without interfering with each other, and it also facilitates the transplantation and use by other programs. In this task, the main function, initialization function, and interrupt function were transplanted from task 4, which is the display function of the digital clock. To implement button adjustment, an external interrupt function is added. The main addition is the function of the external interrupt button, which is written in the external interrupt function. Let's look at the specific program. First, the state of P1 is sent to the variable value, then a multi-branch switch statement is used to determine which button has been pressed. If the value of variable value is 0x7f, it represents that the button K1 connected to P1.7 has been pressed, and the function of adjusting the hour value is executed. Specifically, every time button K1 is pressed, the hour value stored in the variable hour increments by 1, then the second value is reset to 0. If the hour value reaches 24, it wraps back to 0. Then the program exits the multi-branch switch structure, and the interrupt function concludes. Similarly, if the variable value is 0xdf, it represents that the button K2 connected to P1.5 has been pressed, and we need to execute the function of adjusting minutes. Specifically, every time button K2 is pressed, the minute value stored in the variable minute increments by 1, then the second value is reset to 0. If the minute value reaches 60, it wraps back to 0. Then the program exits the multi-branch switch structure, and the interrupt function concludes. Let's take a look at the simulation effect together. After the simulation begins, the initial value displayed on the 8-digit display is 2358, and the value changes once every second, which is the time change function of the electronic clock. Let's look at the function of the button. K1 is the hour adjustment button. The current time is 23 o'clock. Press K1 once, and the hour increases by 1. At 24 o'clock, the hour returns to 0, and the second value is cleared. Pressing K1 again changes it to 1 o'clock, 2 o'clock. K2 is the minute adjustment button. Press it once, and the current minute increases by 1, and the second value is reset to 0. In this task, we use buttons implemented using an interrupt method. Alternatively, a scanning button method could be used, but it would occupy CPU resources. For external interrupt buttons, it generally does not occupy CPU resources. It responds only when the button is pressed, thereby improving CPU efficiency. In this lesson, we have primarily learned about basic logic gate circuits and added the functionality of adjusting the hour and minute values of an electronic clock using external interrupt buttons. After class, please consider how the program would be implemented using standalone buttons. To conclude, here are a few exercises to test your understanding. That's it for this lesson. Goodbye, everyone.